Assalamualaikum warahmatullahi wabarakatuh and good day. So now we continue with hypothesis testing for a population mean. So before I continue with 3.2, from previous video, you can see that you have 5 steps here. Okay, how to do the hypothesis testing traditional approach. Okay, and this one actually is a proper conclusion statement. Okay, that's mean if you reject H null, so how you conclude? At alpha 0.05, for example, there is enough evidence to reject the claim if the claim is at H null and the other way around lah. Okay, so now we move to 3.2, hypothesis testing for a population mean. Alright, so here you can see we concern about a population mean. So is it one mean or two mean? One mean, one population. Okay, so step number 1 is write down your hypothesis testing. So again here you have two tail, right tail, left tail. So how you write? You will have the parameter mu, and mu naught here is a value. How do you get the value? You get from the question. If they didn't mention how many or how much, you will put 0. Okay, so here focus, this is two tail, two area, right tail, left tail. So that is step number 1. And then step number 2 is a test statistic. So for mu, for one population mu, okay, even from your chapter 2, you know that you need to know either the population variance is known or unknown. Okay, so if your population variance is known, if you know this value, this is the Z test that you need to use. You can see the formula is x bar minus mu sigma over square root n. So x bar is a sample mean. Mu naught you get from here, step 1, sigma you known. How do you know? You get from the question. They mention the population variance is known, for example. And then n is a sample size. So the formula is given in your statistical table. You can look. Alright. So, but if your population variance is unknown, okay, you need to check the sample size. Is it the sample size greater than 30 or less than 30? So in this case, if greater than 30, you will use the same thing, Z test, quite similar with previous formula, but here instead of sigma, you have S. So S is what? Is a sample standard deviation. And then if your sample size is less than 30, you will use t-test. And t-test, the formula is similar with this one, but here you will use t-test t-table. Alright? Look this example 3.2. Most water treatment facilities monitor the quality of their drinking water on an hourly basis. One variable monitor is pH. So you can see that the variable that they're concerned about is pH. Okay, which measure the degree of alkalinity or acidity in the water. A pH below 7 is acidic, above 7 is alkaline, and 7 is neutral. So that statement is just information. Okay. A water treatment plant has targeted a pH of 8.5. That's the keyword. The water treatment plant target pH 8.5. Most try to maintain 8.5. The mean and standard deviation of 1 hour test result based on 31 water sample at this plant are 8.5 and 0.16. So you have mean here and then you have standard deviation here. And then here 31 water sample. So from this statement, you can see that you have sample size equal with 31. And then 8.42 is what? Is it x bar or is it mu? If you look here, mean. This mean comes from where? From sample. So it will be x bar. And then you have S, which is 0.16. So that's the information you get. Okay. The question asks you, does this sample provide sufficient evidence that the mean pH in the water differ from 8.5? So that is a statement that you need to check. So you can see the concern about mean, 1 mu, and then the words here differ. So differ here, when you convert to math, it will be equal or not equal. Is it greater, less than? It will be not equal. Alright. And then here, use alpha 0.05. Let's say the question doesn't mention what is the level of significance, what is the alpha value. You must assume alpha equal with 0.05. Okay, and here you can see it's a hypothesis testing question lah, because they didn't ask any confidence interval here, isn't it? So you must check this is the hypothesis testing. So step number 1, write down your H0 and H1. So here you can see we are talking about mu. So here will be mu. And then the word is differ, not equal. Is it H0 or H1? It had H1. Not equal with what? Differ from 8.5. So this is the claim. Alright, so here will be equal 8.5. Alright, so that is step number 1. Okay, step number 1. Step number 2, I know after the next slide is the solution. But just to give you some, if you have this question, how is it? Okay, so that is step number 1. Step number 2. You know this is mu. So mu, it can be Z test or T test, isn't it? First, you must check the population variance. Do you know the value? Do you know the value? No, we didn't know, isn't it? So this is population variance unknown. So when unknown, what should you check? Sample size. Oh, so is the sample size less than or greater than 30? It's greater than 30 here. All right, so you will use Z test. Okay, so Z test, you must look at the statistical table. What is your formula? So this is the formula. You have your X bar, you have your S, you have your sample size, and then mu naught you get from here, right? You just substitute the value and then you get answer here. How many decimal places? 4 decimal places. All right. So look the slide. This is the slide. So you can see this is step number 1. We've done. And then step number 2, when you substitute the value, you get negative 2.7839. Okay. Now step number 3 is critical value and rejection region. So critical value, you must look what? Which table? Right. So look your step number 2. What test do you use? Z test. So that means you will look Z table. Okay, look your statistical table. You will look Z table. And then this is 2 tail or 1 tail? 2 tail. Your alpha from the question is what? 0.05. So the alpha should be divided by 2. You get 0.025. So look your table. Alpha 0.025. What is the value? So if you look the table, it will be 1.96 and negative 1.96. Why you have two value? I mean left and right, because you have 2 tail, and then the value is similar, only the sign positive and negative, because Z and T test you have symmetric figure or symmetric curve. Okay, so this is what you should have. That means you have area figure, left side negative 1.96, right side is 1.96, because this is 2 tail. That is step number 3. Step number 4, you make decision either to reject H now or not to reject H now. So how do you know? Check this value, negative 2.7839. Is it at the dark side or is it at the bright side? So this is 1.96. Okay, this is in between negative 1.96 and 1.96. But negative 2.7839 is a negative. It's at the left side. And this one is smaller than 1.96 here. Alright, so it's at the dark side. So when it's at the dark side, you will reject H now. Okay, so this is how to write it. Since your Z test, negative 2.7839, is less than Z table, which is negative 1.96, then we reject H now. So that's the decision in step 4. Step number 5, draw a conclusion. So look here. When you reject H now, okay, that means you remove this one. This is what you get. Okay, so alpha equal to what? You must put the alpha value. Alpha equal to 0.05. So do you have enough evidence to support the claim? So you can see lah, because your claim is accepted. So there is sufficient evidence to support the claim that the mean pH level in the water differ from 8.5. Okay, so that's how you make conclusion. Okay, at conclusion you must write down your alpha value. Very important, because different alpha will give you different rejection region, and then will different decision as well. Okay, that's why at conclusion, the alpha should be write down. And then look, is it enough sufficient evidence or not? Depends on your step number 1. All right, so this is the exercise. Okay, suppose you try all the exercise because different exercise have different situation. So if you done for all, it will be better for you to understand. Do you understand or no? Step number, but I mean subtopic 3.2. Okay, so I think that's all for today. If you have any question, you can ask your lecturer or maybe you can ask me as well. All right. Okay, thank you, class.